Okay, hold on. We got to recap for Colby. All right, so here's the graph, right? And so what we did is we knew it was going to be a circle, so we put a pi out there. We went from 1 to 3 because they told us to go from 1 to 3. Then we did the curve that's farthest from the axis of rotation, which is 1 over x squared, minus the axis of rotation. So minus -1 is plus 1 squared, all right? Minus the curve that's closer to the axis of rotation, which is 0, minus the axis of rotation, which is -1. So that's going to be squared dx, okay? And then you guys all just slam that onto your calculator? Okay. So if you FOIL this, just for funnies, 1 over x squared times 1 over x squared is 1 over x to the 4th. And then when you multiply these two together, you get 1 over x squared, but there's going to be 2 of them, so you get 2 over x squared. And then 1 times 1 is just 1, right? Yeah. So now the 1's will cancel. So this is the integral. Made a big difference, didn't it? Okay, so then this is going to be x to the -4th plus 2x to the -2, and then the 1's cancel. The antiderivative of x to the -4th is -1/3 x to the -3rd. The antiderivative of 2x to the -2 is -2 x to the -1. Nicely done. And we're doing that from 3 to 1. So pi times, if I put 3 into there, 3 cubed is 27 times 3 is 81. So this is going to be -1 over 81. Minus, if I put 3 into there, it's going to be 2/3. Okay. Minus what you get when you put 1 into there. So that just works out to be 1. So it's going to be -1/3. That just works out to be 1. So it's going to be -2. Well, because -1/3 x to the -3rd is really -1 over 3x cubed. No, because it's to the -3rd. So yes, 3 cubed is 27, but that means 3 to the -3rd is 1 over 27. Okay? It's okay. I accept your apology. I don't know. And then this just works out to be something that we want. Do you want to mess with all these fractions? What is it? Okay. We're just going to assume that that is correct. No, I know, but we're going to assume that this works out to be that. Okay. It does? Like these things do? You did that? Oh gosh, thanks. Well, it's nice of you. You like did the fraction thing on your, yeah, okay. Okay. Huh. All right, so we're doing 15, 16, 17, and 18?
No, my calculator's got a little button.
So it just goes right into fractions?
I have to like set it up in the math, like
right.
do the second math.
Right.
What did you get for about?
Okay, 15. X equals y squared. So we're sideways to start with. Then x equals 1. So that's right here-ish. And we're going to rotate that around x equals 1. So I'm taking this stuff right here and spinning it around this way. Okay? So since we're spinning sideways, that means we're going to go with the x equals, not the y equals. All right? This is going to be a little bit of a brain buster, I think. So I still have pi. What? We're not going to have to subtract anything, no, because when we rotate this around here, we're going to have like a solid object. Yeah. Okay? What? Okay, so we're going from 0 to 1 because, oh, no, we're going this way. We're going the up and down way. So do you want to double it and go from 0 to 1? Okay. So 2 pi times 0 to 1. So we're just going to, okay.
So if I just put it in on my calculator, I just spin sideways and
yeah, pretty much. Yeah. Okay, so what are we taking what are we doing the integral of?
It's y squared minus 1 quantity.
Y squared minus 1 quantity squared. Because this is yeah, right, because this is the curve, and this is my axis of rotation. So I have to go curve minus axis of rotation. Okay? Hopefully we're right. You did? Okay. So y to the fourth minus 2y squared plus 1. You can't do that in these problems because you're rotating it this way. You have to do it like that. So you could do that when we were just finding the area in between the curves, but as soon as you rotate horizontally, then you have to do it as x equals, because your cross sections are going this way.
So it says like about y,
Okay.
it has to be y equals the equation.
Yeah.
So the next one we have to make it x equals.
Yeah, so since it says around x equals 2, that means we're going to have to change this into x equals y squared. Yeah. Yep.
Multiply by pi and 2.
Bless you.
I didn't multiply by pi. So it should be 1.06.
What's the answer to this one? Is it 16 pi over 5? I mean 16 pi over 15? Yeah. Okay.
What's the answer to
These are hard problems. Well, I'm getting them right. I'm feeling pretty good about myself, and I've been doing this for 20 years. Yeah. So 16 pi over 15. What was your question? 16? 8 pi over 15.
yes, I got that one.
Yep, these are challenging. What just happened, Brooke? What?
Well, I knew I did this one wrong.
Yeah.
But I just,
Okay.
It's about the density. We don't subtract anything.
So y equals x. Y equals the square root of x. And we're going around x equals 2. So taking this little thing right here, and we're rotating it around x equals 2. Yeah, we're going to subtract some stuff because we have all this missing space right here. Yeah, in this one right here, the reason why we didn't have to subtract anything is because there was no empty space in between the curve and our axis of rotation. But here, there is all this missing space here, so we have to subtract out what that is. Yes?
So my calculator, how would I get the
You don't. You don't. No.
no way?
There is a way, but you can't do it.
Too complicated.
No, just you can't do it. Because you just have to make it y equals. Okay? Okay. Okay, so this is, again, cross sections are circular, so we've got a pi there. Then we're going from where to where? Remember, technically, since we're rotating horizontally, you're doing the y's, but it's the same, because y equals x, so it's going to be 0 to 1. Okay, who is the farthest curve from the axis of rotation? The square root of x, which we have to change to be x equals y squared. Because the things are going sideways, so we have to use x equals. We can't do y equals, because the radius of these things is going to be Okay, an x distance, not a y distance. So it's y squared minus 2, yeah, quantity squared. So that would give us the whole entire thing. If we, okay, and then minus, we have to take away the stuff on the inside. So that's, yep, that's this thing right here, y minus 2 squared. Why did I get a negative number?
Is it the exact opposite, or is it not? Because you should get 8 times. 8 times.
No, I got negative 12 pi over 15. Yeah. Let's see if I set that integral up correctly first.
Well, your top equation is correct.
16. Oh, they have those switched. They have 2 minus y squared squared minus 2 minus y squared.
Why do you have to do that?
Oh, okay. But it shouldn't matter because, wait. No, that doesn't matter because if you FOIL 2 minus y squared, you get 4 minus 4 y squared plus y to the 4th. Yeah, so it doesn't matter. So that's correct. Why is this giving me a negative answer?
I used to have all the things that you
So where did I?
Oh, thank you, yes. Hold on, it's actually, we call it.
4 minus. Okay, so they end up with y to the 4th. Oh. They have a 4y in there. Where'd that come from? I thought the 4's canceled.
Hey, there's the 4y. It's in
Yeah.
between your y squared and your...
What? Yeah, so you have,
No, those 4's cancel.
No, there's, so look at your y squared minus 4y plus 4.
Y squared minus 4y plus 4,
And so there's your minus... There's
Oh, right there, that minus 4y. Oh.
plus 4y, right?
So it'd be a plus 4y. Got it. Okay. Thank you.
I was missing it too.
That is weird. So there should be a plus 4y in there. Maybe. Okay, so 1/5 y to the 5th minus 5/3 y third plus 2y squared. And that's from 0 to 1. Okay, I love it when it's 0 to 1 because when you plug in 1, it's just all of the fractions. Okay, so this worked out to be, what did I say? 3 take away 25. Oh, negative 22 fifteenths, which is, yep, so 8 fifteenths. Phew! Calculus is hard.
17.
Okay, 17.
So is this where we have to solve for y?
Yeah, because again, it says around x equals -1, so we're going sideways, so we're going to have to do it in terms of y. But we'll just graph it first. Y equals x squared looks like this. And x equals y squared looks like this. So I'm going to take this thing right here and rotate it around x equals -1. Okay? So, I've got a pi, and then I'm technically going in the y direction, but this right here, this intersection point is 0. I'm assuming this one is 1, right? If you plug 1 in for everything, everything's equal. So that's from 0 to 1 of farthest away from the axis of rotation, which is this thing right here, which is y equals x squared. But since we're going sideways, we need to change that into x equals the square root of y. So farthest away from the axis rotation, which is square root of y, right, minus -1, which will really be +1 squared, minus, No, you got it. You're all good. Minus this one right here, which is y squared, minus the axis of rotation, which is, again, -1. So minus a -1 is a +1. Bless you, Baborski. It shouldn't. It should make you feel really smart. It's really, why not? It's super complicated. I know, but you're getting it sometimes. That's so cool. How many people within like 100 square miles can do this?
Probably a lot.
No, not very many. Okay, all right. How many people in Grace Harbor County can do this?
Not a lot of Grace Harbor.
Like 5%, maybe 2%?
And we're the,
You're,
We're not the
You're
1%,
on-
we're the 2%.
I mean, I don't know. You're on top of the heap is what I'm telling you. Shouldn't feel bad about this. Okay, so if you square this, you get y plus 2 root y plus 1 minus, if you square this, you get y to the 4th plus y 2y squared plus 1. So negative y to the 4th, negative 2y squared, plus y. This is brutal.
do you get a lot of y's?
Yeah. And then the ones cancel, but I still have all of this. Did you do it by hand, Mackenzie? Do I have to?
Doing it by hand.
Oh, so I have to do this by hand too? So negative 1/5 y to the 5th
Minus 2/3 y
minus 2/3 y.
cubed. 1/2 y squared. And I haven't done this one yet because I just started.
So you got to add 1 is to the 3/2 and then multiply by the reciprocal, which is 2/3. So it's going to be 4/3 y to the 3/2. Luckily, that's from 0 to 1. So now on your calculator, you can just do negative 1/5 minus 2/3 plus 1/2 plus 4/3. It's what? Oh, man. What? Oh, yeah, it's the right answer.
Why'd you say, oh man?
Just to make fun of you. So that's pretty good. That's a pretty complicated problem. We got it right.
18.
That's pretty awesome.
I got it.
29 pi over 30. So just short of 3.14, Jake. 3.1. Might be from rounding. 18 is 76 pi over 3.
I got, oh, I forgot to multiply it by.
Somehow I got like
Yeah, I forgot.
0.666670873, and then I don't know how I did that, but like why
I have no idea.
I missed it by that much.
Okay,
In number 18.
18?
I'm struggling with these.
It's me too. Calculus is hard. We make a Barbie doll that says that. Y y, I'm not making, are you talking to me? Oh, no, I'm not making fun of you. Y equals 0. I'm not making fun of you.
Are you, what do you want? Move each over there, class plan?
Okay, so we got y equals x. We've got y equals 0. We've got x equals 2. And we've got x equals 4. Okay. And we're going to go around x equals 1. All right. So this time, it's for real. No, this time we're going sideways again. So we have to do the y coordinates. Oh, so we have to, Austin? Thanks. Okay, so yes, we have some issues here, children. We have to break this into two integrals for the first time in our lives. What a great problem to end on. Because for this region right here, this curve is on the outside and this curve is on the inside. But as soon as you get above that, this curve is still on the outside, but now this curve is on the inside. Okay? So we have to do this in two separate things. So we're going to do this piece right here. Okay? This is going to go from 0 to 2, right?
We're doing the y coordinate, right?
Yeah, we're doing the y coordinates. So since I plug in 2 here and this is y equals x, those are going to be the same. So that's going to be the integral from 0 to 2 of the outside one, which is 4, minus the axis of rotation, which is 1. And that should make sense to you, because this is just going to be a cylinder with a radius of 3, okay? Minus the one that's closest to the axis of rotation, which is x equals 2, minus the axis of rotation, which is 1, okay? Yep, so we've got a couple cylinders, and we're taking the whole cylinder minus the inside cylinder, so we wouldn't even really have to use calculus to do this. So that's going to be pi from 0 to 2 of 9 minus 1 is 8, right? 4 minus 1 is 3. 3 squared is 9. 2 minus 1 is 1. 1 squared is 1. So that's the problem. It makes you like start to second guess just normal everyday stuff. So no, because we have to do the antiderivative. So the antiderivative of that is 8y. I'm going from 2 to 0, so that turns out to be 16 pi. Okay, so the volume of that cylinder with the missing piece in the middle is 16 pi. All right, now we have to add on to that this part right here. So that's going to be pi times 2 to 4 of the outside one, which is 4, minus the inside one, which is 1. So that's going to be just 3 squared, yeah, 9, minus. Now this curve finally comes into play. So that's just x equals y. So it's y minus the axis of rotation squared dy. What a great one to end on.
This one makes it
I have 9 minus
So
y
that's
squared.
pi from 2 to 4 of 9 minus, if I FOIL this, I get y squared minus 2y plus 1. So 9 minus 1 is 8, plus 2y minus y squared. Ended up doing that all backwards for some reason. So the antiderivative of 8 is, oh, this is going to be gross though, because it's from 2 to 4. Sadness. So that is 8y plus y squared minus 1/3 y cubed from 4 to 2. So if you plug 4 into there, that's 32 plus 16 is 48 minus 1/3 of 16. What's 48 minus 1/3 of 16 is what? 5 1/3. So 48 minus 5 is 43. Minus another third is 42 1/3. Okay, minus what you get when you plug 2 into there. So 16,
Minus a third.
what?
You said minus 1/3, right?
Thanks. 16 plus 4 is 20. Minus 4/3 is minus 1 1/3. So that's like 19, 18 2/3. And don't forget the pi there. So that's going to be what? 24?
You're really close. We got 29 plus 42.
Did I?
There's 25 1/3.
Oh, all right.
Oh, you're adding them all together. You're really close. But you're not right.
It's 76 pi over.
Which is
Okay.
technically 25 1/3.
Yeah.
Okay, so this is finishing this section. There's a different way that you can do these, and this is hard. No, not a different way to solve the problems, but there's a different way that these problems can be set up, okay? No. So we're going to just kind of work through some of these. Do you remember when we did limits and I didn't know what I was doing? I had to, the trig limits and stuff like that, to look them up, and we're kind of in that situation here, okay? But we're going to just give it a try just anyway, see what happens. So let's say, for example, you have a circle down here. And like I said, this is hard to see on my screen because the resolution of the copying is not really that good. So you could probably see it better in your book. So I've got a circle there. This time, instead of just taking that circle and rotating it, we're just going to make equilateral triangles that are equal to the diameter of the circle and put those all together just because we can. Okay? So it's a solid with a circular base of radius 1. Parallel cross sections perpendicular to the base are equilateral. Oh, I went the wrong way. Are equilateral triangles. I was wondering why that was curved on top. And so we're supposed to find the volume of the solid. So like this is a triangle right there. Okay? Okay, do I have the answer here? Yeah. Okay? So here's what we are doing now. It's the same thing that we were doing before, where we have to take the integral of the areas of the cross-section. But this time the cross-sections are not circular. They're equilateral triangles that are being stacked up on top of each other. So this is a little bit better of a view for us to see what's going on. Here's the circular base, and then you can see a little equilateral triangle there, and a little equilateral triangle there, and a little equilateral triangle there. Okay? Yes, they're always going to be equilateral. Otherwise, it'd be really even harder to do it. Yeah? Right, so great point. So we're not multiplying by pi in this case because we don't have circles, all right? So we have to figure out what the formula for one of these equilateral triangles is going to be, and then we have to add all of those up, okay? So here's a little cross-section of our equilateral triangle. Now, since it's an equilateral triangle, there's a relationship between the base and the height, because if you cut it in half, you end up with two 30, 60, 90 triangles, right? So this is y, and then the height is going to be square root of 3 times y. Okay?
Always going to be root 3 and half of 3.
Yeah. So they have this going down here. So that, well, I guess they don't have that going down there. So the area is going to be 1/2 the base, which is y, times the height, which is the square root of 3 times y. Okay? But we're not using y in here because the width of the base is going to change depending on where you are drawing that equilateral triangle, right? This base right here is going to be different from this base right here, which would be different from that base right there. So the way that base is defined, again, is by this equation right here. So y is equal to the square root of 1 minus x squared. So you plug that in there for y. Okay, so they're doing 1/2. Oh, and then they're saying that, I don't know why they did that way. They're doubling this, right? Because this is only half of the base. They're doing more work than necessary because they're going 1/2 times 2 times that. But do you see that that'll just cancel out? That's why we have this right here. Okay, times the square root of 3, which is this guy right here, times the height, which is, going to be that y again. So this piece right here simplifies to be this right there. I guess I made that way more complicated than it needed to be. All they did is just substituted in the equation for the circle in there for y, and you get that right there.
Is that, so, will we be?
They cancel each other out because there's two of them. Yeah, you'd have to be, or you couldn't figure it out.
It's going to solve for y on that x squared plus y squared equals
Yeah.
3.
Right. Yeah, so they took this right here and just solved it for y. Yeah, exactly. Okay, so once you have that figured out, then you're going from -1 to 1, so that's the integral right here, of the cross-sectional areas, which we just figured out were root 3 times 1 minus x squared. Then they're going to do the doubling trick. So they're going to change this, instead of being the integral from -1 to 1, they're going to make it 2 times the integral from 0 to 1 of the square root of 3 times 1 minus x squared. So 2 root 3, you can pull that out. The antiderivative of 1 is x. The antiderivative of x squared is x cubed over 3. Plug in your numbers and you get a final answer of 4 root 3 over 3. Okay? So that is like, let's play again.
So does that only work with?
No, we can do whatever shape we want. So now we're going to do squares.
With any shape we want.
Yeah, any shape we want. Okay?
Well, if we're doing the squares, why don't we just?
Okay, so the next one says find the volume of a pyramid whose base is a square with side length L and whose height is h. Okay, so this is a pyramid on its side. The height right here is h, and the base right there is L. Okay, so this time our cross-sectional areas are all squares. Okay, you know that the area of a square is just the side length squared, right? All right. And so then they took this thing here and substituted that into stuff that will work for us. But before they did that, there is a relationship using similar triangles between the height, the entire height of the pyramid, and the length of the base, and the height of, some random ones and the width of that. So this length right here over the entire thing is equal to, they can't use the whole thing there because the similar triangles have to be right triangles. So they did S over 2 divided by L over 2. That ratio is going to stay the same. You know that from geometry. You guys are all doing the right thing, just staring at me, hopefully thinking about something else more interesting than this, but just being like, yeah, sure, totally got it. Okay, so X over H equals S over 2 over L over 2. Okay, so we can take this then, and if I take this and solve it for S, what does S equal? Multiply both sides by L, yeah, so you get L times X over H, right? So that means our cross-sectional area, instead of being S squared, is this stuff squared. So it's L squared over H squared times X squared, okay? So all we need to do is just add up those infinitely small squares between, looks like 0 and h, because that's the height of the pyramid. So if I do the antiderivative from 0 to h of L squared over h squared times x squared, the only variable in there is the x. So the antiderivative of x squared is x cubed over 3. This one stays the same. Then I plug in 4 and I plug in 0, and I get L squared times h over 3. Because that is a constant and this is a constant. That's the height and the width. Right, and so the antiderivative of, pretend that this was just a 5 right here, the antiderivative of 5x squared is 5x cubed over 3. Okay? All right. So that's fun, huh? You want to try one more? How much time do we have? 5 minutes? Let's see what the next one is. Okay, so then you could also do that with semicircles in a cylinder. Okay? Because that's really just not that much fun. So we are not going to try and do any of these problems on our own, but just so you can see that you can use this to find volumes of solids that are generated in other ways just by taking curves and rotating them. Okay? But it gets, I mean, it's the same idea. You have to find a formula for the area of the cross-section, whatever shape that may be, and then just do the integral of all of those infinite ones.
So next will be